In this video, you will learn how to use descriptive statistics and visualizations to better understand your dataset in Neural Designer. This exploratory analysis is essential because it helps you detect patterns, outliers, and relationships that could influence your model's performance. Let's start with the iris flowers example. We open Neural Designer and, from the menu on the left side of the screen, click on the Examples button. All the available examples are displayed, and we select the iris flowers example. Click on Calculate Variable Statistics on the Task Manager tab. Neural Designer will automatically compute the statistics, and once it's done, the Neural Viewer window will open. The tables that appear provide a complete summary of your variables, including basic metrics and distribution information. Neural Designer automatically computes essential statistics such as minimum and maximum values and mean and standard deviation. These measures help you quickly assess the quality and behavior of each variable. For example, we can see that the maximum sepal length in the dataset is 7.9 centimeters, while the minimum petal width is just 4.3 centimeters. Since class is a categorical variable, no statistics are shown. However, because class is also our target variable, the next tables display specific statistics for each of its categories: iris setosa, iris versicolor, and iris virginica. This allows you to quickly compare how each class behaves across the different input variables. For instance, when looking at petal length, setosa has values ranging roughly between 1.0 and 1.9 centimeter. Versicolor is noticeably longer, from around 3.0 to 5.1 centimeter, and virginica is the longest, with values between 4.5 and 6.9 centimeter. These differences highlight how well separated the classes are, which is why the iris dataset is often used as an introductory classification example. By reviewing the statistics, you can identify potential outliers or unusual values before moving on to model training. For example, extremely large or small values, unexpected categories, or inconsistent distributions. Detecting these patterns early can guide you toward necessary cleaning or transformations, ultimately improving your model's performance.